శ్రీ ముత్తవరపు వెంకటేశ్వరరావు కాలేజ్ ఆఫ్ ఇంజనీరింగ్ అండ్ టెక్నాలజీ 2008 లో స్థాపించిన కళాశాలలో MBA, NAC A గ్రేడ్ మరియు ISO సర్టిఫికేషన్ సాధించిన మొట్టమొదటి కళాశాల శ్రీ ముత్తవరపు వెంకటేశ్వరరావు కాలేజ్ ఆఫ్ ఇంజనీరింగ్ అండ్ టెక్నాలజీ త్వరలో అటానమస్ కాబోతోంది.
2014లో ISO గుర్తింపు, 2015లో రాష్ట్ర ప్రభుత్వంచే A గ్రేడ్, 2016లో NAC A గ్రేడ్, ఇప్పుడు NBA సాధించిన సంస్థ శ్రీ ముత్తవరపు వెంకటేశ్వరరావు కాలేజ్ ఆఫ్ ఇంజనీరింగ్ అండ్ టెక్నాలజీ.
Good morning students, I am Harsha, assistant professor from the department of EEE. I am going to teach the subject for 3rd BTech first sem students, and the subject name is renewable energy source. All in the previous session we have discussed about solar air heaters. In this session we are going to learn a new topic about a solar ponds. So let us see the basic introduction about solar ponds. So in this main outline is to what is the basic introduction and what is meant by solar pond, what is a solar pond, and what is the working principle of the solar pond, and what are the different types of solar ponds available, like non-convecting solar ponds and convecting solar ponds, and what is the maximum efficiency of the solar pond, and what are the advantages and what are the applications and conclusions. So let us see the basic introduction of solar ponds. If you see, you know all the solar energy. For the solar energy, the sun is the main source in order to get the renewable energy from the sun. Okay, so it is very abundantly available in all parts of the earth. It is in fact of one of the best alternatives to the non-renewable source of energy. So you know all the solar ponds are very large scale collectors and heat storage for the supplying thermal energy, and it can also be used for various applications like heating, water distillation, refrigeration, drying, and power generation also. So but in most primitive manner, some research and development has been carried out for the few countries to export the solar energy for the different sources. So in the previous session we have learned about solar thermal energy, solar thermal power plants, and solar air heaters. In this session we are going to know about solar ponds. So but the most of the work will be remained mainly in academic. Okay, so let us see about the solar pond construction and working principle of the solar pond. So the sun is the largest source. I am repeating again. So sun is the largest source of renewable energy, and it is abundantly available in all the parts, and for the best alternatives to the non-renewable source of energy. So let us see the next slide. So what is meant by solar pond? There will be a huge space will be taken, and this huge space will be constructed with a pond of water, and it stores the water in the pond, and it is a body of water that collects the solar energy. So and this pond of water is filled with salt, and the it reaches the surface, and the water loses its heat to air through convection and or evaporates, they taking heat with it. So the cold water which is taken for this pond, and the output of this solar pond will give the warm water. From the warm water again it is sended through pipes, and it is sended to the steam turbine, and it will steam generator. This steam generator will produce the steam, and this steam will heat the turbine. Your electrical energy will be generated. So by using this solar pond, you can store the heat much efficiently than the body of the water the same size, because the saliently, and it is prevent conventional current. So in order to store the heat collected by the pond, so the solar pond reduces the either convection or the evaporation. So the heat will be stored by using this solar pond. This heat will be send it through steam generator, and from the steam generation you will get your steam, and it hits the turbine. Your electrical energy will be generated. Okay, So this is about basic introduction about the solar pond. I am repeating again. So what is a solar pond? So there is a land requirement here. In this land requirement, you will take a space of pond, and it is filled with water, and the source of water is also very important, and it should be filled with water, and and there is a salt in the water, and three layers will be there in the pond, and under deep of the earth of the water there will be an salt. So this salt will be heated. I have already told you in the previous slides. So this salt will be heated by the sun, and approximate temperature will come, and this temperature will be used to store your heat, and this heat will be sent it to the tubes, and in order to this steam, I mean to say, this heat will produce the steam, and this steam will hits your turbine, and the mechanical energy is given to the generator, and it will be converted into electrical energy again. So the source requirement in order to construct your solar pond is land requirement is important, and in this land requirement there should be a water source, and you need to collect the salt, which is nothing but a molten salt, and this molten salt is filled in this water pond, and solar and water will be heated in the layer. Okay, and this water inlet and outlet has to be taken, and from the inlet you will fill it this pond with cold water, and the hot water will come from the output of the outlet of the solar pond, and this outlet of the solar pond of the heat water will come. This heat water will transfer through the tubes, and I mean to say pipes. It will enter into these steam, and it produces this heat water will go through the steam generator, and it generates the steam, and this steam will hit your turbine, and your electrical energy will be generated. So this is about solar pond. I'm repeating again. So the water warmed by the sun expands and rises, it's become less dense. So once it reaches the surface, the water loss, it hits to the air through convection and evaporates, taking heat with it. So the cold water is which is heavier moves down to replace the warm water, creating a natural convection circulation and mix the water and dissipates the heat. So this from this ultimately we are dissipating the heat, and this heat will be stored, and it will be converted into steam, and the steam energy will be converted into electrical energy. I mean to say, this steam will hit the turbine, and the mechanical input will be given to the generator. It will be converted into electrical energy. So it can store the heat much efficiently, and the body of water with the same side and conventional way current will come for you by using this solar pond. So let us go for the next slide. So let us see what is the working principle of the solar pond. The solar pond normally consists of three zones. So one is you can see the picture here. One is upper convective zone, another one is non-convective zone, another one is lower convective zone. If you observe, if you see this picture, so the sun rays will reflect on this water, and whenever the sun rays hits this water from the upper zone, it will enter into this non-convective zone and the lower convective zone. So most of the heat will be stored in the lower convective zone because of the salt which is filled in the water. The molten salt easily heated more, and it will be used for the generation of electricity. So if you observe these three zones, so three important zones in the solar pond, one is upper convective zone, another one is non-convective zone, another one is lower convective zone. So upper convective, if you see the upper convective zone, so it is adjacent to the surface, and there is a homogeneous convective zone that serves a buffer zone between the environment fluctuations at the surface and conductive heat transport from the layer below. So the top layer is the upper convective zone, and the bottom layer is the lower convective zone, and the middle zone is the non-convective zone. So the mainly at the upper convective zone, the heat will be taken from the upper convective zone, and slowly it enters into this lower and non-convective and lower convective zone. Most of the heat will be generated from the lower convective zone. Okay, so like this, the upper convected zone acts, it is a buffer zone between the environment fluctuations at the surface, and it is a top and the conductive heat transport from the layer below. So next one is intermediate gradient zone. The intermediate gradient zone, what is meant by intermediate gradient zone? So a gradient which serves as the non-convective zone, which is much thicker and occupies more than half, and the depth of the pond salt concentration and temperature increases with the depth. So if you observe carefully, it's the gradient which is is a non-convective zone and which is much thicker and occupies more than half depth of the it is an very less gradient zone, and very half of the depth of the pond it will be occupies, and the salt concentration and the temperature raises increase with depth. Okay, and lower convective zone, this is the highest salt concentration zone, and where the high temperatures are built up, and I have already told you. So the concentric zone, where it is the higher, and it the temperature will be built up in the lower convective zone because of the highest salt concentration in the lower convective zone. So almost as thick as middle non-convective zone. So in order to maintain the solar pond in this non-equilibrium stationary state, it is necessary to replace the amount of salt that is transported by the molecular diffusion from LSZ to USZ. So there are some chemical reactions in order to prepare the salt in the solar pond. So, and the surface area of the pond affects the amount of the solar energy it can be collected, and the dark surface at the bottom of the pond increases and absorbs the solar radiation. So like this, we have some chemical salts like manganese chloride, sodium chloride, and the sodium nitrate, and dissolved in the water. The concentration being densities at the bottom 20% to 30% and gradually decreasing to almost zero at the top. So the maximum heat will be generated by the salts. So because of the molten salt, so this molten salt will be heated by the sun, and it will be heated easily more, and it gives more heating temperature. And so at the bottom the pond increases, the absorption of the solar radiation will be more under the lower convective zone. So this is about different working principles on the upper convective zone and intermediate convecting zone and lower convecting zone. So what I am going to say is, in order to work this solar pond, there are three types of zones. One is upper convective zone, another one is non-convective zone, another one is lower convective zone. So these are the three important zones in order to build your solar energy. So at the lower convective zone, and another important thing is here, so the salts like the manganese chloride and the sodium chloride, which absorbs the more solar radiation in the salt, it will be mostly 20 to 30%. So this is about working principle of the solar pond. So let us go for the next slide. So you can observe the different types of solar ponds. So there is research has been done on these solar ponds, and we have three types of solar ponds. One is convective solar pond. First one is convective solar pond. Another one is non-convective solar pond. Like this, we have different types of solar ponds. So if you observe the picture of the solar pond, there is an extruded curbing and black pond liner and insulation, earth, moisture barrier, water, air, and these are the three layers here. There is a plastic blanket on this here, and in order to example for this convective pond is, it's a shallow solar pond, and the pond consists of pure water, and in this conventional solar pond, it is the pure water is used in order to absorb the heat from the sun. And there is a blackened at the bottom there is a bag here, and it has an foam insulation, and two types. One is plastic or a glass, and the sun heats the water in the bag during the way, and at the night the hot water is pumped into a large heat storage tank to minimize the heat loss. So this excessive heat will send when pumping the hot water to the, so you have to pump your cold water from the inlet of the solar pond, and you have to take the hot water, and again the hot water is pumped to the turbine, so in order to generate your electrical energy. So it is hot water to the storage tank has limited development of shallow solar ponds. So this is the one type of solar pond, which is the bag is inserted the plastic sheets, so which absorbs the heat more, and plastic or a glass like that. We have different sources, so depending upon the sources we have to use this foam insulation in order to absorb the solar radiation more. So this is about convecting solar ponds. Let us see about non-convecting solar pond also. So again another type of solar pond is available here. So the main types of non-convecting solar ponds is salt gradient ponds, and non-convecting, which is non-convecting. So one is convecting. In the convecting we will use a fiber or a glass on the convecting solar pond. If you use non-convecting solar ponds, so under the water there it is filled with a mixture of salt and water. So the main type in these non-convecting solar pond, it is a salt gradient ponds. If you tell, if anyone tells it is about non-converting solar pond, means it is a solar gradient pond. And a solar gradient pond has 3 distinct layers, and it is of a mixture of salt and water. So with the concentration, and the most concentrated layer forms at the bottom, and you know there are 3 layers. At the bottom layer you have a low concentration layer. On the low concentration layer the salt will be more, and it is a mixture of salts like sodium chloride and manganese chloride. So these chlorides of chemicals will absorb quickly the radiation of the radiation of the sun. So a dark colored material, usually rubber lines like the pond. As the sunlight enters the pond, and the water and the lining absorb the solar radiation. So whenever the sunlight enters the pond, so lining absorbs the solar radiation. So as a result, the water near the bottom of the pond will be nearly 93.3 degrees Celsius. Even when it becomes warm, so the bottom layer remains denser and the upper layer does the inhabitation convection. So pumping the brine through an external heat exchanger, so there will be an external heat exchanger in order to produce the steam, and evaporator removes the heat from this bottom layer. And another method to heat removal is to extract the heat with a transfer fluid. It is pumped through a heat exchanger placed on the bottom of the pond. So I have already told you, I have already shown the picture of the solar pond. At the top layer there is an layers, 3 layers, top layers and bottom layer. At the bottom layer there will be another intermediate layer also. At the top layer the cold water will be there, and at the intermediate layer it is the heat absorption layer comes, and at the bottom of the layer, so the bottom of the pond, the most radiation will comes to the bottom of the layer. Most of the salt will be heated at the bottom of the solar pond of the water. So whenever it absorbs the heat more, and it is at the bottom of the layer, the salt is filled in the bottom layer of the pond. So whenever this bottom layer of the pond gets absorbed by the sun, and the heat will be generated at the bottom layer. So this heat will be transferred through pumps, and it is sent to the heat exchanger, and it produces the steam. So this steam is sent to the through tubes and through pipes and tubes, and it is sent to the steam turbine. So whenever it hits the turbine, so the electrical energy will be generated. So the mechanical energy will be converted into electrical energy. So let us go for the next slide. You can see here the flow diagram for the solar power plant. So here you can see the solar radiation comes and hits the solar pond. So whenever it receives, so it is sent to the boiler, and the evaporator boiler will generates the steam, and it will be heated to the turbine. So another end you can see the pump, and pump is sent to the after the water is heated, so it will be sent to the condenser, and the hot water will be sent to the cooling tower, and the water will be cooled again. So this is the process here. I'm repeating again. So you can see the solar pond. From the solar pond it is sent to the evaporator boiler. So there are two inlets here in order to send the water into the solar pond. So one inlet is cold water and another inlet is hot water. So whenever the cold water is sent into the solar pond, and it will be heated with the salt, and the solar it will be heated with the salt, the sunlight. Whenever the sunlight hits the water, and under the bottom, it generates the heat, and this heat will be transferred to the evaporator boiler. So this evaporator boiler will be transferred again to the turbine, and to the turbine it will be sent to the generator. So you will get an electrical power output. So if you see the another end, there is a pump here, and it is sent to the condenser in order to cool your water, and it will be the hot water will be sent into the condenser, and it will be the cooling towers will cool the water and send it to the pump. Okay, so this is about a single line diagram for the solar pond of an electrical power plant. So let us go for the next slide. So what is the efficiency of the solar pond? So the energy obtained is in the form of low grade heat of up to 70 to 80 degrees Celsius as compared to an assumed 20 degrees ambient temperature. So according to the second law of thermodynamics, so the maximum efficiency of the cycle that uses at high temperature reservoir at 80 degrees Celsius has lower degrees of 20 degrees Celsius. So you will get maximum efficiency at the high temperature with 80 degrees Celsius and with lower degree temperature of 20 degrees Celsius. So here you can see the low grade heat will be 70 to 80, and it will be compared with 20 degrees ambient temperature. So if you want the maximum efficiency, so in order the maximum efficiency will come at the higher temperature reservoir at 80 degrees Celsius and a lower temperature at 20 degrees Celsius. So here the efficiency formula is here. So 1 minus Tc by Th. So this is the formula, and you have to write the formula. 1 minus what is the temperature you will getting, and you have to do it with adding, and you will get 17% of efficiency. Okay, so this is about efficiency of the solar pond. So what are the advantages of solar pond? It is very environment friendly, and there will be no pollution. So it is one sort of renewable energy source, and it can be used for many purposes such as generation of electricity and heating the fluids. So it is one main purpose in order to generate your electricity by heating of the fluids. So and another one is no need of separate collector for these dermos. So in the previous session we have seen that flat plate collectors like that, and we have some concentric collectors like that. So no need of using all these collectors in this solar pond energy. So no need, and it is very low maintenance cost, and it can be main purpose such as generation and electricity and heating of the fluids. So this is about advantages of solar pond. So what are the applications of the solar pond? If you see in India, the first solar pond was built at Bhoj, which is in Gujarat, and the project is under sanction under the National Solar Pond Program by the Ministry of Non-Conventional Energy Sources in 1987, and it is completed in 1993. After a sustained collaborative effort by TERI, the Gujarat Energy developed the agency, and it has been constructed like this. So you can see the images of the solar pond at Bhoj and in Gujarat. And what are the applications? I mean to say in any other areas like that. So and another largest operating solar pond of the electricity generation was Beit Harwa pond built in Israel. And in Israel we have another big solar pond. So it has an area of 2,10,000 meters square, and it is used to generate an electrical output of nearly of 5 megawatt. So the solar powering 20% of Bruce Wood Corporation, and in Texas, in US also we have these solar ponds. So let me conclude about this solar pond technology. So the solar pond technology has tremendous progress in the last 15 years. The solar pond can be effectively used as a replacement in industries and that use fossil fuel to generate thermal energy. Solar ponds can be used for processing heating and for the refrigeration, water distillation and product of manganese chloride and bromine require recovery from the beat and enhancement of the salt yield in the salt forms. So it is the future energy source. You can use this solar energy. So it is very important. We have different advantages and disadvantages of the solar energy. So this is about solar energy, and if you have any doubts, free to call me, and I hope you all understood. Thank you all. We will meet in the next session.